Hi, I am Kelly Parkinson, and this is the citric acid cycle. So the citric acid cycle is commonly known as the Krebs cycle. It was discovered by Sir Adolf Hans Krebs, in which he won a Nobel Prize for the discovery in 1953. His colleague Franz Albert Lippmann also won a Nobel Prize for his discovery of coenzyme A. So the cycle typically takes 8 steps, and in one single turn of the cycle, one molecule of acetyl-CoA produces 2 carbons to enter the cycle. Once they enter, 2 carbon dioxides are released. It then produces 3 molecules of NADH and 1 molecule of FADH. And all of that results into ATP, 1 ATP. The glucose that's produced results in 2 acetyl-CoA. So, in the first step, acetyl-CoA combines the 4-carbon acceptor oxaloacetate, and you then get citrate, a 6-carbon sugar. In step 2, it is a removal of water and adding water back in. So it's a 2-step process of citrate to isocitrate by H2O. Step 3 is when isocitrate oxidizes to release carbon dioxide. Alpha ketoglutarate is a result of that, and an oxidation reduction reaction results in the formation of NADH from NAD+. So this is an important part of the cycle because it essentially determines the speed, because isocitrate dehydrogenase catalyzes the reaction, and that determines the speed. Step 4 is the oxidation of alpha ketoglutarate. It reduces NAD+ to NADH once more, releasing more carbon dioxide. So that would be the second carbon dioxide, as we talked about in the beginning. Alpha ketoglutarate also picks up coenzyme A, and it forms an unstable succinyl-CoA. Enzymes catalyze the reaction, resulting in alpha ketoglutarate dehydrogenase. And in step 5, coenzyme A of succinyl coenzyme A is replaced by a phosphate group. A phosphate group added onto ADP, so ADP is diphosphate, so 2. That makes ATP so triphosphate, so 3 phosphates. So you add on a phosphate group to 2 makes 3. A 4-carbon molecule is succinate. Step 6 is when succinate is oxidized into fumarate. Hydrogen atoms are transferred from FAD to FADH2. So 2 hydrogen atoms. Water is then added to fumarate to form malate. And in step 8, the final step of the citric acid cycle, oxaloacetate is regenerated by oxidizing malate, and so a redox reaction occurs with the transfer of electrons from NAD to NADH, and essentially that starts the entire cycle over again. Thank you.